Hi, I'm Kurt. I'm working with Christian, Elijah, and Louie, and our capstone project is flutter prediction using Swift, which is the small-scale wind-impelled fan tunnel. So our problem that we're hoping to address with this is that current wind tunnels for flutter testing are far too large, as you can see in the picture, and are very costly for use by small entities. And the reason why this is important is that flutter is very dangerous, and there needs to be a cheaper way to test it. And advanced wind tunnels are normally extremely large, so if we can make a small one, that would definitely help matters. And our need statement is that we need to develop a product that can predict and test flutter on a scaled down aircraft wing for people who work in the aeronautics and astronautics industry and educators as well. And the main thing is that it needs to only require a small space for use.
Some existing solutions right now is a open return wind tunnel, which is in the top right over here, which uses the air around the environment. Then there is a closed return wind tunnel over here, which uses vanes, which help turn the airflow. And then the last existing solution is a blow down wind tunnel, which is over here on the bottom right. And you can see that it uses a pressure vessel and then the airflow model here, and then a lower pressure vessel. And then all of the competing companies that make these wind tunnel designs is NASA, Boeing, and Capstone. Our solution right now is, with the including of a position statement, is for people in the aerospace and education industry who need a way to test flutter prediction. Swift is a wind tunnel that predicts flutter at low cost and use commercially off-the-shelf parts. And this is basically the wind tunnel that we could use easy accessible parts that would basically predict flutter in our aircraft wing.
So in terms of market size, we kind of split the market into two different parts, the commercial side, the general aviation side. So in terms of the general aviation side, as of 2017, the revenue was $150 billion. Civil aircraft as a whole was 5.1%. And then it's projected to decline between 2020 and 2040 at about 1%. But when you round this per year, you have very minimal changes that are close to about 0%. So this will be a steady market in the future. And in terms of the commercial market is expected to grow at about 1% a year between 2020 and 2040. And in terms of how we're going to target our market size for Swift, we're going to focus more on the commercial side, understanding that there is a greater potential for profit in the commercial side, but also have customers as well in the general aviation side, because regardless of economics, it'll be a steady business plan.
All right. So who's our customers? Well, we start our project. Our initial customers are going to be aircraft manufacturers, research institutes, and safety administrators. So we're going to be focusing on satisfying their needs. And then we're going to start satisfying our next possible customers, who are lab demonstrators, schools, small-scale aircraft operations, and maybe even hobbyists. And we think about how can we satisfy them. And as for our initial customers, well, we want them to continue funding us and making materials more accessible to us. So what we're going to do is to use that money and material to create multiple prototypes to make sure that, hey, we're doing what we want you to do with your money. Tell them that, hey, the project's going well. We got the project under control. And then we're going to start making our product more kind of accessible for customers to buy our product. So that means to make it more accessible, make it low cost, make it simplistic and compact, but also satisfying the needs for our initial customers.
So the business model that we're going to roll with is that for the first product, we're looking at direct purchase by business and direct purchase or rental by customers. And the reason for this is that the big tunnels are very expensive and they're very cost prohibitive, and we want something to combat that. And for the second product, which is going to be the improved one, we would want direct purchase by business and direct purchase or still renting by private customers, and with a possible licensing option for businesses so that they can produce it themselves.
And then our management team here, we have Christian as our project engineer business lead, myself as the aerodynamic engineer, we have Kurt as a systems engineer, and Louis as a design engineer.
So in terms of milestones, we have 8 specific milestones that we have listed. First off is just the preliminary CAD model of both the prototype, wind tunnel, and the wing. Then we have our finalized CAD model of those respective components. We're going to order our prototype materials. We're going to then begin the wind tunnel assembly. Our goal is to start testing our prototype in early May, be able to have enough data to compare with the theory by the end of May, and then we'll be presenting on June 10th, and our finalized report and our final prototype to the customer will be done by June 15th of next year.
Thanks for listening, everybody.
Thank you.